find the limit. The limit as x goes to infinity, the natural log of x divided by x times the natural log of x. If we try to evaluate this immediately using the quotient rule, as x goes to infinity, remember the graph of the natural log of x, as x gets larger, the natural log of x is going to get larger. So that goes to infinity. Well, as natural log of x goes to infinity, the natural log of x goes to infinity. X is going to go to infinity. Natural log of x is going to go to infinity. When you multiply them together, you'll go to infinity. So this is quickly an indeterminate form. And we try LHopital's rule. So by LHopital's rule, we would have the limit as x approaches infinity of the derivative of the numerator. The derivative of the natural log is 1 over the natural log of x times the derivative of the inside. The derivative of the natural log of x is 1 over x divided by the product rule. X times the natural log of x. The derivative of x is 1 times a copy of the second one, natural log of x, plus a copy of the first, times the derivative of the natural log of x, which is 1 over x. So this simplifies down to 1 over x times the natural log of x divided by the natural log of x plus 1. Well, we can combine this thing together, may be helpful. Natural log of x plus 1 is the same as natural log of x plus 1 divided by 1. And so we divide fractions by multiplying by the reciprocal. And when you multiply those together, notice that x times the natural log of x, as x goes to infinity, we've already talked about that in fact, x times the natural log of x goes to infinity. So this goes to infinity, which means this whole fraction goes to 0. Natural log of x is going to go to infinity, which means natural log of x plus 1 goes to infinity. The denominator, therefore, is getting larger and larger and larger, so the whole fraction gets smaller and smaller. Excuse me. So the limit will end up being 0 times 0, which is 0.